Hey friends, thank you for watching this video. I am Mohamad and today we'll be starting our journey exploring AWS. The first thing we're going to be discovering is AWS Lambda. So what are we going to be covering today? First, we're going to start discussing what is serverless cloud computing. Then we're going to be discussing the difference between traditional and serverless. Then we're going to discussing what are Lambda functions, why do we need them, how do they work, and then we're going to jump more deep in how can we build those Lambda functions. Then we're going to be digging deep into certain functionalities and certain aspects of the Lambda functions. Then we're going to be discussing the ingredients that we're going to be using in order for us to build our solution, and then we're going to be jumping into coding. As always, please comment your questions, suggestions in the comments down below. Please like, share and subscribe if you like this video. It will really help the channel. Now, what is serverless computing? Serverless computing hosts and run code in the cloud. It is serverless in the sense that you don't need to install, maintain, service to run, which means no infrastructure headache. The infrastructure is already set up and it's already configured for us to utilize. Serverless computing eliminates this infrastructure barrier for developers, and as well it eliminates the complexity for managing a server. So, let's first discuss what is traditional deployment. We can go through the step of building a traditional or deploying a traditional application through traditional deployment, and then from that point forward we can actually check how serverless works, and then we can compare the two together. With traditional deployment, we need to do the following steps. First, we need to get the server based on our application and our need. So we need to decide if it's going to be a Linux or a Windows server, if it's going to be a dedicated server or it's going to be a shared server. Once we have decided on these, the next step is to do the configuration. First, we're going to install IIS if it's a ASP.NET, for example, server, and then and then what we need to do is we need to configure the pipelines, we need to configure the firewalls, we need to install any dependency that we might need. We need to give all of the right permissions that we need in order for our application to run. And once all of these configurations are set up, the next step is for us to actually deploy our code. Deploying our code to that service can be, for example, through FTP, or we can download that server directly to download the source code directly to the server. There's different way to do that. But once that code is actually deployed, what we need to do is we can actually give it the right permission to run. So we need to give it the right permission to access different system services, to access the right IIS management services, so on and so forth. So once we do all of that, the next step is to secure it. So how do we secure our server? It could be, for example, from defining the firewall. It could be from closing some ports. It could be, for example, to give certain access to certain local environment. So let's say we're uploading certain file. We only give the ability for those files to be stored in a certain directory in our server, and prevent any access for different directories through that file, prevent malicious files from being uploaded, making sure that our server has the latest security updates and patches, and so on and so forth. So these are the 4 steps that usually that we take in traditional deployment. But the work is not finished there. Once we actually finish these 4 steps, we need to do some server management. So basically, every now and then we need to update to the latest version of the server. We need to install all of the dependencies, updates for every dependencies that we have. We need to make sure that all of the server is running correctly. There is no, for example, processes that's taking all of the memory or all of the CPU. We need to monitor all of these, and as well we need to always keep the security updated. So any new security patch we need to install. We need to make sure that the firewall is working as it should be. We need to keep doing security tests against the server, and so on and so forth. Once we do all of those, we need, for example, to keep an eye to resolve any issue that might rise. If the application crashes, we need to find a way to actually log all of the crash logs, and then we can monitor them. We need, for example, to build some monitoring tool in order for us to get notification in case something goes wrong on our server. So there's a lot of hands-on management to the server after the application is being deployed. It's not like we deploy it once and we forget about it. It's like a continuous steps and continuous management that we need to do. All of this work, it requires some experience, and it requires some really heavy experience when it comes to managing these servers. So we need someone who actually knows how to set up networking, someone who knows how to configure Windows services, as well as to configure different instances, for example, from security perspective as well. And all of these are not actually part of the developer's job. because basically the developer will only need to care about the application running on that server, but not actually have to deal all of this configuration that the servers require. As well, there is gonna be, with different applications, there's gonna be different types of servers. So for example, one application could be built on .NET and it utilizes Windows Server, another server could be built on Node.js and utilize a Linux server, and so on and so forth. And all of this, we still did not cover one of the main problems that we might face, which is scaling. So right now, once we configure our application, and let's say our application is already configured to handle like 10,000 connections, which is good. Let's say, for example, our application goes viral, and all of a sudden, instead of 10,000 connections, we are getting roughly around 100,000 connections or 200,000 connections. It will be really hard for us to scale that server. What we need to do is we need to pump up new servers, do all of the same configurations, and then we need to add some load balancers, and then we need to route traffic. Maybe we can have like an API gateway, and basically it's gonna be a really hard time in order for us to actually scale all of this. So as we can see here, with traditional deployment, there's a lot of steps, and there is a lot of things that we need to take into consideration rather than just deploying our application. This is where Lambda function differs. So with Lambda functions, we can see here there is only basically two steps. First, we need to get access to the Lambda environment, which is going to be our AWS account, and the second step is actually just deploying the code. It's as simple as that, because basically AWS will take the responsibility for it to actually configure everything that we need. It will take responsibility to managing the service infrastructure, to keep all of the security updates in place, to make sure that in case there's any logs, we are able to see it, and so on and so forth. So basically AWS is going to be doing the heavy lifting when it comes to hosting and managing our servers. All we need to do as a developers is to worry about deploying our code and making sure it's running correctly. As well, AWS will also give us the ability to auto-scale as much as we want. So for example, every request that we do, it is first of all, it's measured by milliseconds. So we can set some rules to see if, for example, if one request is taking, for example, 3 minutes or 4 minutes to run, we can actually scale up more instances of our AWS Lambda functions, and any new request can be directed from there. And there is so many ways we can actually scale up and scale down our application, and it's very good for us because we are able to save money and basically have an optimum output of our application. We can discuss the benefits later on, but these are the small benefits that we can actually get directly through deploying with serverless computing. So that way we can see that there's a lot of differences between traditional and serverless. A lot of the headaches that come with traditional is not with serverless, but every one of these two has their pros and cons. And right now, although we just focus on the cons of the traditional, but there's a lot of benefits as well that comes with traditional. If you want me to delve into more information about that, please let me know and we'll make a video about traditional deployment. In different aspects, we can see that even with these small snapshots, serverless cloud computing really is a very powerful tool which allows us to directly deploy our code without worrying about anything else. So, what are Lambda functions? AWS Lambda function is a serverless compute service which let us run code without managing or provisioning any servers, maintaining, even integrating and managing runtimes. So what does that mean? In essence, it means that we can actually deploy our code, and AWS will be responsible to managing every single thing related to the infrastructure. It will be managing the updating of the infrastructure, making sure that it's secure, updating the security rules, updating all of to the latest environment, installing all of the patches. For us, when we upload our code, we just take a small space on the AWS Lambda servers, and basically AWS will take care of everything else. All we need to do is make sure that our code runs and we can deploy it there. AWS Lambda function is the response to Microsoft Azure function as well to serverless compute service. It allows us to run code with zero administration as well infrastructure knowledge in order for us to run our code. Once we upload our code to AWS, it will run automatically. And that's the beauty of it. Why do we need it? First, because there's no servers to manage. AWS Lambda automatically runs the code for us without requiring us to provision any infrastructure. We just need to write our code and just deploy it. The second is continuous scaling. So AWS Lambda automatically scaled our application by running the code in response to each event. So basically our code will run in parallel and process each trigger individually. So for example, there is no repetition of events. So for example, one event is being handled separately than other events. So that way we can show, for example, if one event can take up to 5 minutes to run, that events are going to be running separately on AWS than other events. So for example, let's say our server has 10,000 requests coming in, we're going to have 10,000 events running simultaneously from our code through that AWS Lambda function, which makes it very fast. It makes it that we have all of the right allocation for every request, and there is no stress on the server, which might affect the performance of other events if one of them is taking much more time than the other. So basically our code will run in parallel and each process will run individually, and scaling is precise. So for example, we can run from 100 requests per day or to 100,000 requests per second. That's how powerful Lambda functions are. Then we can see another benefit of AWS Lambda is cost optimization, because basically our costing is gonna be measured by milliseconds. So the more optimized our code, the less time it is gonna require to run, the more cost efficient it is for us. So everything is tied to the running time and the amount of resources that it utilized. So the more our code is optimized, the less costly it will become. So rather, when a traditional deployment, yes, we have like a dedicated server, even if we're not using it at all, we have to pay for those resources. When it comes to Lambda functions, all we need to pay for is the resource when we actually use them. So if we are not using them, we're not paying anything. Consistent performance. So with AWS Lambda, we can optimize our code execution time by choosing the right memory size for our functions. So we can also choose, for example, if we're gonna have this function already preloaded to the memory, so it will be directly executed without actually waiting for the time for that function, for that request to hit the AWS servers. Then the servers need basically to load the Lambda function into memory and then execute it. There's a lot of optimization that we can actually do in order for us to get the best outcome, but basically AWS with different configuration allow us to have out of the box high performance and consistent performance no matter what the requests are. As well, AWS Lambda function support multiple programming languages. So for example, we can actually utilize C#, we can utilize Node.js, we can utilize Java. It allows us to build on different types of languages no matter what backgrounds you come from. And lastly is going to be the integrations. Since it's an AWS service, it has built-in integration with different AWS services. So it could be, for example, SQS, SNS, EC2. We can actually build and integrate with a lot of the AWS services through the AWS Lambda functions. So how can we invoke Lambda functions? Lambda functions are event-driven. So this attribute refers to how the code is being executed and how Lambda functions are. A function basically will start via event. So the event could be, for example, an HTTP trigger, a message, for example, through SQS, through the queue. For example, there's a message, a function could pick it up, or for example, there could be another Lambda function which calls another Lambda function and it can invoke that Lambda function. And there's dozens of invocation to choose from. For example, as we have mentioned, these are the most common three. For example, HTTP trigger, message, SQS or SNS, or Azure functions. But if you go to AWS documentation, you can see a whole list of other invocation that we can actually utilize in order for us to invoke Lambda functions. It could be even a webhook or anything that we want. So services integration, as we have said, since AWS Lambda functions are part of the AWS family, we can integrate with different AWS services out of the box. So we can integrate with Kafka, we can integrate with DynamoDB, we can integrate with Amazon SQS. So for example, with DynamoDB, we can generate some certain file or certain information, and we can store this information in a NoSQL DB, which is going to be DynamoDB. We can actually, for example, we can execute something on our AWS Lambda function, and basically input or create a message to a certain queue, and that queue, for example, will be picked up by a different service. That message will be picked up by a different service. Or we can actually save logs into Kafka, and then we can stream those logs into a different service that we can actually use using. So there's a lot of potential when it comes to a service integration and how we want to build our functions. It's not like we're just building this one function and it's basically stopping there. It's completely opposite. It's just a portal for us to actually build and expand our application through the different integrations that AWS provide for us. So in summary, we can see here that the invocation can be from an HTTP request, from an SQS, SNS, or a Lambda function, and it could go to a different function. So it could be, for example, Kafka, DynamoDB, Message Bus, or an AWS Lambda. So there's a lot of ways that we can actually invocate functions as well as integrate with different functions through AWS Lambda Functions. Now, what are the ingredients that we're going to be needing in order for us to build? So the first thing is we're going to be utilizing VS Code, which is going to be our code editor. As well, we're going to be utilizing the .NET 5 SDK. We're going to be installing some different packages, and for that we're going to also utilize Homebrew, and for those we can actually see how we can install them once we actually start our coding process. Now let's get started. In order for us to build and develop Lambda functions locally, we need to download some packages and some stuff in order for us to be able to utilize AWS and actually build the Lambda function. So what do we need? We need to download the AWS CLI as well as a lot of AWS packages. And since I'm already on a Mac, the best way to do it is to utilize Homebrew. So basically, Homebrew is like a package manager. It's one of the best. And if you're on a Mac, I really recommend to download Homebrew. So in order to get Homebrew, all you need to go to homebrew.sh, and here you can find the installation process to download Homebrew. All you need to do is basically copy this and paste it in your terminal. I have already installed it, but it will tell me it's already installed. It was going to ask you for your password. And continue, and basically right now it's gonna update Homebrew. I have already installed it, so it's not gonna take a lot of time. Perfect. Now Homebrew has been installed successfully. Once that's done, right now we need to install packages. So the first package that we're gonna be installing is basically we're gonna install the AWS SAM CLI. So how do we do that? First, we need to type inside terminal brew tab AWS /tab. Basically what we're doing here is we are actually accessing a repository, which is basically the package repository from Homebrew, and we're telling them that we want to actually open the AWS repository on our machine. Once we do that, the next step for us is to actually install it. How do we do that? We utilize brew again and utilize the install keyword, and then we're gonna type AWS -sam -CLI. I have already installed it. As you can see here, for you it might take a few seconds to install. Once that's done, now we need to type brew install AWS CLI, a single word. Just take a few seconds. I have already installed it. As you can see here, it says that it's already installed. So once we have done that, the next step for us is we need to download Visual Studio Code. You need to go to code.visualstudio.com and download it. As well, we're going to be utilizing the .NET 5 SDK. You can also go to .NET.microsoft.com/download/.NET/5.0, and you can download from there. These links will be available in the description down below. And after we've done all of that, we need to verify that the .NET SDK has been installed successfully, and the way to do that is we need to type .NET --version, and we can see I have the latest version installed, which is 5.0.400 by the time of this recording. Once we have done that, the next step is for us to configure AWS locally. And basically, in order for us to configure AWS locally, we'll need to have an AWS account. If you don't know how to set up an AWS account, all you need to do is go and type AWS console, and it's gonna take you to like a registration page. You can create a free account and you can set up your information from there. This should take you roughly around a minute or so to do. Once you have done that, you need to create an IAM user and generate a key and a secret. There's a lot of resources. If you need some help to do if you need some help in order for you to generate this, please let me know and I'll make a video on how we can generate IAM credentials and how we can set them up. But once we have generated them, what we need to do is go back to the terminal and we need to type AWS configure, and basically here we're gonna configure the credentials for the AWS local on our machine, so it will be automatically able to connect with our AWS instances. So once we type that, basically we need to type the AWS access ID that we have generated, then we need to type the secret key that we have generated, what's our preferred region, and then basically the output format. And once that is done, we have already configured AWS. Great. Locally on our machine. So the next step after we do that is we need to install some dependencies for .NET so it will be able to communicate with AWS and generate AWS templates. So in order for us to do that, what we're going to be doing is we're going to type .NET tool. So it's a tool basically we need to install, and we're going to type install. We're going to make it -G because it's global. We want to make it available everywhere, and then we're going to make it amazon.lambda.tools. And if we hit enter, we can see the tools have been already installed, but for you it might take up for like a minute to download and install. The next step is another tool for AWS that we need to install is .NET tool install -G. Also we want to make it global. That's going to be amazon.lambda.test tool. So this will allow us to run AWS Lambda functions locally and test it out. -3.1 because basically we're targeting .NET version 3.1. And once we do that, we can see that it has been already installed on my machine. For you it might take up for a minute to be downloaded and installed. So once we have done that and we have installed everything, now we need to create our AWS Lambda function locally. So how do we do that? It's very easy. We need to utilize the .NET new keyword, and you might be surprised, but because since we have installed the amazon.lambda.tools, it will update our .NET new capabilities, and it will automatically allow us to install Amazon services or basically initiate new Amazon projects for .NET. And if I click .NET new here, basically what's going to be doing here is going to show me all of the available templates that I can utilize. And if you notice something, that after we have installed the AWS amazon.lambda.tools, we can see that we have all of these new templates that have showed up for us for AWS, from, for example, customer runtime environment to detect images to DynamoDB stuff to ASP.NET Lambda, or so on and so forth. There's a lot of AWS stuff that we are able to directly create from our terminal and basically build AWS projects from our machine. Right now what we're going to be utilizing is we're going to be using the lambda.empty function because we're going to build it up and test it out locally. So that's what we're going to be doing. So we're going to put .NET new lambda, and basically we're gonna put empty function, and then basically as we do with any ASP.NET project or .NET project, what we need to do is give it a name, and that name we're gonna call it my cool function, for example. And once I click on enter, this should take a few seconds to be created. Perfect, now it has been created for me. And then all I need to do is just go to that function and open it up in my code editor. So I'm going to be utilizing Visual Studio Code to open it. And as we can see here, it has opened in Visual Studio Code. Great. So now basically the first thing we're going to be doing is we're going to go to View and we're going to open our terminal. And inside our terminal, we're going to navigate to the source file, and we're just going to type .NET build. Basically we're going to build this project. Oh, there's another folder, so cd my cool function, and then over here we're going to type .NET build, and we can see the application is being restalled and build is succeeded. Great. Once we have done that, now let's examine what do we have here. So the first thing that we have here is we have two folders. We have source and we have test. Source is going to contain all of the source code for our application, for basically our Lambda function, and the test is going to contain all of our tests in order for us to test and do unit test against our Lambda function. So inside the source folder, we open it and we have my cool function. This is the application name. And then inside the folder my cool function, we can see that we have a normal ASP.NET application, which is we have a normal .NET application, which is going to contain a CS proj, a function. As well, we can see a lot of a class, and we can see that there's a lot of configuration, which is basically related to AWS Lambda, which is basically this configuration folder, which basically give a lot of information related to that Lambda function that we have right now. We're going to explain this in details, but for now what we're going to be doing is let's open the function.cs and let's see what's here. So if we go first, we can see that it's basically utilizing the normal or including the normal project libraries, system, collection, link, so on and so forth. And then basically we can see that it has the amazon.lambda.core. And if we go to the mycool function.cs proj, we can see that when we actually initialize this project through the .NET new, two packages has been installed. So the first one is amazon.lambda.core, which basically give us access to all of the Lambda capabilities and SDK locally on our machine, as well as the other one basically is going to be the serialization, which basically allow us to serialize objects directly into our Lambda function. So these two packages here, we can see that one of them is being currently installed, which is going to be the amazon.lambda.core, which will be utilizing the using, and the other one that we can see here is basically the Lambda serializer, and it's actually being referenced through the assembly. So it basically what means here that we're referencing it through the assembly. It means it's going to be available for us anywhere within our Lambda function. So it's not going to be only linked to a single function or single method. It's going to be available anywhere. We can move this later on to a single method to test it out, but for now let's leave it here. Next, we can see that we have the normal namespace that .NET generates, and we have a normal class which is called function, and basically this is going to be the main entry point for our Lambda function. And inside of here we can see we have a very simple method which is gonna call all it does is to take an input and make it to upper. But let us examine what's happening here. So first of all, we can see that this method basically represent, if we're talking as a console application, it's gonna be basically public static string main args So basically this method here, the function handler, is very similar to the main method that we have inside our console application. It's gonna be the entry point that we have. As well as we can see that this method basically, what does it do? It basically takes an input and has an output, and it's very simple to that. So as we can see here, those input right now are consisting of strings and a context. So you might think to yourself, okay, I know what a string is, but what is an Lambda context? So basically a Lambda context is the ability for us to connect with different Lambda services or AWS services that is provided to us through the SDK. So once we actually deploy this to AWS, we'll be able to connect with those services. So for example, let's say I want to log stuff. What we can do is we can context dot logger dot, for example, log, and I can say test. And this way, whenever I deploy it to AWS, I will be able to actually see these logs coming out in the portal inside AWS. So this is a very powerful thing for us to actually utilize right now. So for now, we can see that we have this very simple method, which basically only take an input, which is a string, and make it to upper. So let us run this and see how it works. So you might think to ourselves, okay, this is a serverless function. And basically if we're gonna run it locally, we don't really have the infrastructure for it. How are we gonna run it? And as well, if you look at it here, you don't see the main method, which basically handles as a console application. So how it's gonna run? If you remember, when we installed our packages, what we installed is this. Let's go back to it. And we installed this tool here. It's called .NET tool install amazon.lambda.test tool -3.1. And this test tool here, basically what does it do? It mimics a Lambda environment on our local machine. So it mimics an AWS environment on our machine, so we are able to run the Lambda function locally. Yes, so once we have done that and we have made sure that it has been installed, let us run our function locally and see what do we get. So how do we run it locally? First, let us build our application. We can see it has already been built, but let us build it again because we did some changes. So we're gonna put .NET build, and once we put .NET build, we can see it built successfully. Now let's clear it out. And once we have done that, we need to actually call that testing tool. So how do we call that testing tool? Because it's a .NET global tool, we need to utilize the .NET keyword at first. And once we utilize the .NET keyword, we need to type lambda tool, sorry, test dash tool dash 3.1, which basically here what we're saying is we're calling the tool that has been installed. So once it has been installed, it has that name locally on our machine, and when we type .NET lambda test tool 3.1, it means that we're actually initializing that environment of AWS locally on our machine, and it's smart enough to pick up the project that we are currently in and build it up from there. So once we hit on enter, it's gonna do some work and some magic. And once it does that, it's gonna we see here that has already created an environment for us, which is running on port 5050. So let's go back to our web browser, and inside our web browser, let's open this port, and we can see here that we have a mock environment already available for us out of the box directly from AWS, and all we need to do right now is just test it out. So we can see here that all of this information is automatically being populated for us because it's being picked up from the AWS Lambda tool default.json, which is basically it's this JSON file here which contain all of the information that we have. So basically that tool, or basically the environment right now, it's reading this JSON file to be able to populate and know exactly how it should configure the AWS environment locally on our machine. So once it know how it actually gonna do that, it basically populate this, and right now we're just gonna leave everything default except here the input of the function. I'm just gonna say Mohamad, I'm gonna give it my name, and if everything goes to plan, we should basically see here in the response Mohamad all capitalized. And all I need to do is just click on execute function, and it gave me an error. So let's see what's the error that it gave me. System.exception, these are JSON. Okay, so the main issue is because it's requiring an input string, we need to put this inside quotations. So let's put this inside quotation and let's execute it, and we can see that we have here Mohamad all in capital letter. Now let's change this, for example, to .NET, and let's write again, and we can see it's all in capital letter. Perfect. Okay, great. Now what the next step that we're going to be doing is basically we're going to be creating a class which is going to represent a DTO, which is the data transfer object, and then we're going to pass a JSON file here and actually process a JSON file. So let's see how we can do that. Let's stop the application first, and what we're going to be doing here is basically we're going to create a new class, and we're going to call it public class, and we're gonna call it say weather DTO, and basically this class is gonna contain let's say we can call it an ID. Let's see, and we can make another one which is basically a string name. Very simple. And once we do that, the next step is basically we need to actually update this method here in order for us to take the JSON object and process it. So how do we do that? So the first thing we need to do is we need to remove the string here, and we're gonna replace it with the weather DTO, and instead of input I'm gonna just call it data, and I'm gonna update my function here. So basically I'm gonna create a string, so we're gonna make it info, for example, and we're gonna use string interpolation to do that. If you don't know how to use string interpolation, I have another video. It's gonna be linking on the top right hand side here, which we delve more into string interpolation and the different methods that we can actually use. It's very helpful. So if you don't know how to use string interpolation or a different feature of string interpolation, I highly suggest that you watch that video. But for now, let us create a simple string, and we're gonna call the ID is, and we're just gonna pass the ID data of the city, and we're gonna pass the city here, data.city, name. Okay, great. So now what we're gonna be doing is I'm gonna pass this info here, and I'm gonna make it to upper. Very simple, straight to the point. So how I'm gonna do that, or how I'm gonna run it right now, similar to what we did last time. Let's clear this up. We're gonna put .NET Lambda dash test dash tool dash 3.1, and we can see it's running. And now let's go back to our web browser and let's refresh this. And what we're going to be doing here is we're going to be passing a JSON. So we're going to have to create our curly braces. We're going to give it a name, an ID first, and the ID is going to be basically 1. And then we're going to give it a name, and this name is going to be, for example, Beirut. And let us run this. I think we need, let's see if everything is saved. Yes, everything is saved, everything is as it should be. What's the issue? Oh, that's a very good find. What we need to do is, after we do any changes, we need to build the application, because basically when we run the .NET Lambda test tool, it does not rebuild our application for us. So the DLLs are still based on what we did last time. So this was a very good example. So in order for us to get the latest version of our function and we can actually test it on, we need to build it. So we're gonna put .NET build, and now we're building the application, and we can see here that the bin has already been updated with the latest one. And now if we run the .NET Lambda dash test dash tool dash 3.1, and now if we go back to our web browser and refresh this, and let's put this information again, it's gonna be ID, it's gonna be 1, name, it's gonna be Beirut. And now let's execute, and we can see that the actual sentence is here. This one is not, it says my equal function. Let's see why. Oh, we didn't put an ID, so let's put an ID here. Let's save it, let's stop this, let us build our application again. Let's clear it, and now let's run it again in the testing environment. And now let's go back to our web browser, let's refresh, and let's try it again. So we said ID 1, name Beirut, and now let's execute it, and we can see the ID is 1 of the city Beirut. Great. So now we saw how we can actually send a JSON and process it and actually see the outcome, and how we can utilize the Lambda mock test tool that AWS provided for us through the tool that we have installed for .NET. Okay, great. Now that we have covered how we can create Lambda functions and how we can actually test them locally, this is gonna be the last part that we're gonna be covering today. Please like, share, and subscribe if you like this video. It will really help the channel. If you have any questions, please write them down in the comments down below. The next part is gonna be more advanced Lambda stuff, basically how we can deploy it. I create a much more advanced Lambda, how we can utilize different AWS services with it. This was just a simple introduction to Lambda and the different utilities that it will give us. Thank you very much again for watching. Have a great day.